Hello everyone, we'll see some more example on deterministic finite automata. The language here is that strings start with a double A. Every string will always have first two symbols as A followed by A. So what is the deterministic finite automata for this language? Start with Q naught, reading an A, move to the next state, reading one more A, move to the next state, make this state as the final state. And after these two A's, we can have any combination of A and B. Now complete the diagram by showing the transition of B on Q naught. We will never have string starting with a B. So once the machine sees a B, reject this string. Send it to some state which is a trap state. Similarly, when string starts with an A and on Q1 it sees a B, the first two symbols should not be AB. So we will never have string starting with A followed by a B. So send it to Q3. So this is the deterministic finite automata for the given language. See the next example. Strings do not start with a double A. It should not start with a double A. So for the strings should not start with a double A, we will have to see what strings are accepted by the machine. A null string is accepted, so make Q naught as a final state because a null string is not having a double A, is not starting with a double A, so it is accepted. Similarly, single A is accepted by the machine because it is not single A is not starting with a double A, so it is accepted by machine. But this A followed by one more A should be rejected. See, if the string starts with an A, no problem in it, accept it. But this A is followed by one more A, that is the first two symbols becomes double A, so send it to Q2. Q2 is a trap state. Complete the diagram by showing the transition of B on Q naught. When Q naught sees a B, accept this by sending it to some another state, Q3. Similarly, when Q1 sees a B, send it to Q3. And on Q3, we can have any possible combination of A and B. So this is the diagram for string that do not starts with double A. See the next example. Strings do not have double A as a substring. Substring, we should not have strings with having a double A as substring. Null doesn't have double A as a substring, so it is accepted. Any number of B's should be accepted because it is not having a double A as a substring. Single A, any number of B's followed by a single A should be accepted. But this A, after this one more A should not be accepted. Once the machine sees an A followed by one more A, it will send it to some state which is a trap state. So now complete this diagram. What will happen if Q1 sees a B? Take one situation. If I put this B here, is this the right diagram? No, it is not. Why? Because we will have situation where a string this kind will be rejected by the given machine. But it should be there because this A followed by double B followed by A is in the language. But anything for this diagram, I have A, B star and then followed by one more A is going to state Q3 and it will reject this form of string. So therefore, what we have to make the correction, don't put this B here. For Q1 on reading B, take it to Q naught. Now this is the correct form of the deterministic finite automata for the given language, where any number of b is accepted, null is accepted, any number of b followed by single a is accepted, any number of b followed by a single a, one more b, or any number of b is accepted. If there are any number of b's followed by a single a and one more a, it should go to the trap state and reject it. So now see the next question. Strings do not end with a double A. It should not end with a double A. Okay. Null is not having ending with a double A, so it should be accepted. Any number of B's are not ending with a double A, so it should be accepted. Any number of B followed by a single A, it should be accepted. And one A followed by one more A, take it to another state, Q2, but don't make Q2 as a trap state. This A followed by any number of A, remain on Q2 only. Once Q2 sees a B, take it back to Q0. Take it back to Q0. And if Q1 sees a B, take it again to Q0. So now this is the diagram for strings do not ending with a double A. Suppose I have some string A, B, A, B. Is this string accepted by the machine? Yes. We can see that Q0 will read an A and it will go to Q1. Q1 on reading B will go to Q0, and Q0 on reading A again on Q1. Q1 on reading B is going on Q0, which is an accepting state. So the machine is accepting this AB, AB. But suppose if I have some string B, A, A. So Q0 on reading B stays on Q0. Q0 on reading A is going on Q1. Q1 on reading A is going on Q2. And Q2 is a non-accepting state. See, BAA is read. The whole string is read by the machine, and machine halts or stops at state Q2, which is a non-accepting state. So therefore BAA is not accepted by the machine. But we haven't made Q2 as a trap state because we do not know which is the end of the string. Let us assume one more example. Suppose we have the same situation where BAA is there, the string BAA is there, and this BAA is followed by 1B. This should be accepted by the machine. So therefore B on Q0 on reading B goes on Q0, Q0 on reading A goes on Q1, Q1 on reading A goes on Q2, and Q2 on reading B, Q2 on reading B is going to state Q0, which is an accepting state. So therefore the string BAAB is accepted by the machine.